I think we're skipping acid base just for the time. I'm doing a few activities that I think will take a lot of our time, so we're not going to. Acid base. It's not going to be on. We're not going to do it all. Yeah. Okay. The only thing that will be with acid base reaction, because we've discussed that already a couple times. Okay. So in this chapter, there's like a paragraph. It's really not that long at all. There is a paragraph on the bicarbonate buffer system. Ask you a question or two on, but it's something we have already discussed about how the blood, because it's in the blood. This is a system that is present in the blood to maintain the proper pH, and how certain reactions can push it to acidic or to basic reaction before. So I could possibly, or I will, ask, maybe a question from that reaction. Okay. So let's do the water electrolyte balance stuff. I think I'm going to need the whiteboard here. Do you guys like the lights on the board, or do you want to? Here? Oh. Okay. So urinary system, we looked at how we're cleaning the blood. Okay? But along with cleaning the blood is monitoring blood pressure via blood volume. Also electrolyte concentration, particularly sodium. Sodium is tightly controlled about how much sodium cannot urinate out. Okay? Okay, so how does the body regulate our fluid? How much fluid do we have? How much? You're like a walk-in water bag is what you are. Yeah, it can vary, depend again on size of people and that sort of stuff. But just to give an average number, let's say 50 liters. You are 50 liters of water. A water bottle, all these water bottles, that's probably half. It's probably 750. 500. That's only half. That's, I think, 500. So inside your body, and that's how much water you have. Really walking bags of water. Okay, which means we got to regulate that. We have to, water does everything. Your cells, your concentrations, your action potentials have to do with electrolytes. I mean, it's so important to have the right amounts of water. With this whole water deal, is to recognize where's the water at. So the first learning objective I have, I'm gonna write it down. Identify, students will be able to identify the major fluid compartments of the body. Okay. Sorry. That's all right. I want to think about this one. These two are just going around. Okay, so this next activity, I'm not going to, there's going to be one that I want to do in little groups, and you'll turn it in, and then I'll project them. The other two, you can just sketch them in here, all notes. Okay, so, oh shoot, I forgot. I need my book to do this. Hold on. Tell those stories or something. Okay, so what I want you to do is you're going to make a figure out. So there's a section in your book that didn't really have a figure. So make you think, right? You have to analyze. I'm gonna have to read. Making figures really makes you analyze the material that you're reading. It makes you analyze it and apply it, which is really one of the big skills we're working on. Okay. All right, this right here. In your notes, and you can do it with somebody next to you. This can be, you can talk about it. Make a figure with this right here. This describes our bodies. There really isn't a figure. Come up with your own figure. Come up with a figure. Don't look up a figure. Use your brain power and draw a sketch of something that would represent this right here. The different fluid compartments of the body. Okay? Take about 5 minutes to do that. And you can talk, discuss. For all of them, right? Yeah, just one figure. How would you do it? There's different ways to do it. Creativity, I know. Creativity needs to be stimulated.
Do a pie chart.
Yeah. Yeah.
That's a good one too. As long as you're okay with your pen. What is So you have like X, Y, Z. What is that called? In that picture, so it's the flow in the vessel, right?
By the end of this class, it's like they're all gonna be able to picture into writing. I don't think the ground is gonna be calling. And then I'll show you what I would do. And I just came up with this font here. So I'm gonna try to move back.
Yeah, see, all of this, yeah, I started my high and I was just trying to show, not necessarily that water flows within this direction.
All right, so I think you've had some good discussions about what the food departments are in order to come up with some kind of figure that you would use to represent these different items. Something that there's all sorts of different ways to do this, right? I mean, making a figure, there's charts, there's flowcharts, there's actual pictures, there's all sorts of things you could have done. I'm in the same boat that I'm not an artist. So I would do, the first thing I thought when I saw that is a scale of some sort. So I would say, well, here's my 100%, right? And then we have two first major divisions. So in my mind, I'm like, all right, let's take 65, about there, so 65% is intracellular fluid. So I'm going to draw me the atom nucleus, okay? If I was really using a textbook, maybe add some more organelles, okay? But then I just add a label in here, intracellular, and maybe in here as well, I put my 65%. Okay, done, inside the cell. That's what I would add. 35% is the one that gets a little more involved, okay? Tissue, blood plasma, and the rest. Okay, so we got transcellular fluid, right, keep colors consistent, is about 2%. So that's something in here. 8% was the blood and plasma. It's something about, I don't know, what, right there? So that leaves 25% here. So maybe I would add my values. So 20, 70, let's make this 90 right here. Maybe something like that to show the different divisions, something like that. Okay. All right, and then the tissue fluid. Maybe I draw a bunch of cells this time. Okay, quite a few cells, and then maybe I show fluid. Okay, and then I add a label. Tissue fluid. Some arrows to show what I'm trying to refer to. Okay, my 8% for blood and lymph. Maybe I just draw the vessels. All right. What? And lymph. We wanted to get really technical. We can look at those individual percentages because that's what they think they say. Numbers. Okay. And then my last little bitty 2% is a long list. So I was thinking what I would do here is just make a bulleted list. Like eye fluid, cerebrospinal fluid, vitreous tumor, I bullet it and just make a list. So, there's all sorts of ideas of how to do this. But this practice of making figures is excellent in learning the material. One, you have to analyze what is saying quiet to make a figure. Okay, so this is a good skill to use when you're trying to learn any information, is make a figure out of it. Okay? Okay. Next, like this. So all day long you lose water and you gain water. So let's look at how we lose water and gain water throughout the day. The different, a lot more mechanisms that we kind of just initially think of. When you think of gaining water and losing water, usually the only thing we think about is drinking water and then urinating water out. There's really a lot more to it than that. Okay. All right, so on your left side over here is how we gain water. Water in more ways than just drinking it. Okay? You make your own water. How do you make your own water in your body? 2 ways you make water. 2 reactions. How do you create water? 200 mils, right? Yeah. 200 milliliters per day, which is still not that much, but we'll get to aerobic respiration and dehydration synthesis reactions. These are, but let me real quick jog your memory aerobic respiration, we're taking glucose plus oxygen. This is a whole process to do this, right? Aerobic respiration, we got glycolysis, citric acid cycle, electron transport chain. Those words ring a bell a little bit? Okay, so that's this arrow means that whole process. In the end, this out carbon dioxide, a waste product, plus what's our last molecule? Water. Okay, so this is the reaction for aerobic cellular respiration. Okay, so that's one way to make water. So the other thing is, as we do this, the whole point was making ATP. And cellular energy out of this process. Dehydration synthesis reactions. Remember these? Could you draw a sample? Remember a sample? What's an example of a dehydration synthesis reaction? Any ideas? Okay, synthesis. So we're going to make something.
Down molecules and recombining.
So the synthesis part, we're talking about the recombining part. So what are some things we can make in your body? Take glucose, okay? Except for now I'm going to draw it as like this. Okay, so this is the actual molecule. This is an oxygen. Okay, so this is glucose. What if I take another glucose? These two are the same. What if I take a glucose plus a glucose, and I want to stick them together, okay? So that I have this ring here, this ring over here, and they're joined in the middle by an oxygen in the middle. What's the molecule called?
Disaccharide.
I hear a whisper, a disaccharide. Which disaccharide?
Water?
Sounds a die.
I'm forgetting. That's what I'm thinking. Yeah, it's maltose. Okay, this is maltose. Maltose is a type of sugar. You'll find maltose in like chewing gum. Or malt, the dairy product malt. You get a shake or a malt, right, at Route 66 Diner. A malt has this malt sugar in there. So it's a type of sugar. So this is called maltose. It's a disaccharide. It has two put together. It's called maltose. Okay. Well, in this reaction, okay, we created we have to add water. So this one uses water. Yep, we're going to use water in this. The one that creates water would be going the other way. Sorry. Yeah, breaking it down. So when you add water, to get these two to bind, you use the oxygen from water to bind them together. Okay, so that's the synthesis reaction. The degradation reaction takes the water out. So it comes out. Okay, so that reaction will create water. The breaking down, not the synthesis reaction. Okay, so but anyway, these are different ways to get over here. Water is metabolic water. Okay, that's a small percentage. Your food, okay, different foods have different percentages of water, but you get some from that. And then obviously drink is your biggest source of intake or gain of water. Loss of water, feces, expired air. You see that on cool days, right? You see your breath because you're seeing the moisture condense. So even in warm days, you lose water. You don't lose as much, but you still do. Cutaneous transpiration and sweat. These are different. Sweat is when, you think of you getting sweaty. You go exercise, or you're hot, you're warm, and you get these, water on you. That's sweating. Cutaneous transpiration, you actually lose more water through that. That's just sitting here right now, you're losing water. Okay? Your blood vessels and everything running along your skin is, the water is evaporating. It's diffusing across those membranes and evaporating. Not a lot, right? The whole point is for the blood to go back and come back and circulate and all that sort of thing. So it's not much, but a consequence is just, if we have a cup of water just sit here, right? It's gonna, as the day goes along, it's just gonna evaporate into the air. So the same thing happens with you. Okay, your water is just leaving your blood vessels and your lymph vessels. Okay, it's different than sweating. Sweating is coming out of a pore, a sweat pore. But another way to lose water there. And then urine, obviously the biggest way to lose water throughout the day. The goal is to keep these equal. Okay, you should gain as much water as you lose. So you should be somewhere equal throughout the day to keep you healthy, to keep your body functioning, running, cells doing their deal. Okay? Okay, so what if we do get off though? Here. What if in our blood molarity is for some reason drops to right? Okay. Okay, osmolarity, about what is our blood? What value in milliosmoles is our blood? You know this number? Yeah. It's a, oh gosh, she's asking me a foreign question. 300, we talked about this last week. The blood coming into the nephron. We mentioned that it comes in at 300 milliosmoles. So that's where it starts. Okay? So let's say 300. I'm going to make my blood vessel a little bigger. A little more room to draw. Okay, 300 is about milliosmoles, is about normal. The number is a little less than that, but that's about right there. Okay? What if our body drops the blood too low? Or what if our body drops it too high? What are we going to do to get back to normal?
Coming in, if it comes in too low, too high.
Yeah, how are we, these numbers, how do we get, if it's too high, how do we get back to 300? How do we get up to 300? What are we gonna, let's start with water, okay? Here, with water, what are we gonna do? What are our options? You can either gain water or lose water. You got 50-50, okay?
You lose it.
So if you wanna become more concentrated,
You lose water.
you want to drop your water concentration. So we need to have more loss. We need one of these to increase, both sides of the urine. How about over here? What if you want to go the other direction? What are we going to do with water? You're going to gain water. Can you see how gaining water will dilute out this number and pull that number down this way? So it's diluting it out. How about sodium? All right. What are we going to do to sodium here if we want to increase concentration? What is sodium going to do?
Decrease.
Go up. And over here, go down. Okay. In order to become less dilute, take 320 down to 300, we are going to take sodium out. We're going to take concentration away and add water. That'll dilute it out a little bit. Okay? Okay. So I told you our options are, you can either drink more, pee less. Okay? Drink more and pee less will increase your water consumption. Okay? So you want this situation if your blood has become a little concentrated for some reason. Okay? Maybe you're not drinking enough, you're becoming dehydrated. If you're becoming dehydrated, this number is going to start creeping up. Okay? And then you get thirsty. Thirsty will make you drink more. We're going to talk about what causes thirst. Okay? Or our other option is drink less and pee more. Would be this over here. Okay? More often, we run this way, right? People don't hydrate well enough. It's just something, your thirst mechanism doesn't kick in until you're quite dehydrated, okay? So you tend to dehydrate, get thirsty, and then drink, okay? It's most people don't drink, because to keep yourself well hydrated, it's a habit. It's a social habit of having a water bottle out and sipping all day long every time you walk by it. It takes a habit to really have the hydration that you're supposed to have. And many people don't have those habits, right? Okay. So, in order to control this, drink more, pee less, drink less, pee more. We have some hormones we're going to talk about. Yeah.
Didn't you say we're usually on the left side? Is that where you place on the blood vessel?
We're usually over here.
Oh, okay, I thought that.
Yeah, my arrow got crossed.
Oh, okay.
You gotta follow this arrow. We are normally a little more concentrated.
Is that why your urine sometimes gets darker?
No, darker, yes. If you get the darker, yellowy, orange, almost orange color, and then it's more odor too, 'cause it's more concentrated. It'll have more of a smell to it. That's why. Okay, urine should really be a lemonade yellow, a light yellow, if you're real hydrated. And many people don't get that. Plus, it's kind of an aside, just one real quick. Patients. I'm going to be working with patients, maybe in a clinic or setting, hospital, something. This is a big deal. If somebody's just, for example, bedridden, controlling the fluid is difficult. You can get fluid into them, but the fluid coming back out can be difficult. Okay, they're not sweating. Urine regulate. It's just hard to regulate this if you're not being active out there. So it's something you will deal with patients a lot, is making sure their fluids and electrolytes are balanced. Heat exhaustion or heat stroke. Okay, that comes when you're sweating so much. Okay, when you sweat, you also lose out the salts. Right. Often, or what can happen, is people drink just waters. If you drink just water and not the sodium, you become so dilute that your electrolytes are all off and you get sick. The stroke part means because your electrolytes are off. Okay, so that's why those Gatorades and stuff are good when you're sweating. They're not good right now. You shouldn't be having no Gatorade. Okay, water. Okay, when you're losing a lot of salts and electrolytes. Okay, 2 hormones is where I was headed. What 2 hormones?
ADH.
ADH and aldosterone. Okay, these are the 2 last things we're going to talk about today. We passed it out at 1:45, right? Always passing that. Okay, this next figure, I want you to do on scratch paper, so I'm actually going to collect them. Okay, so be sure you're working with somebody around you. This is addressing speech. little more detailed than what your book is. This is the one I can imagine might take it on. Okay, so here, well, let me put it on the other screen too. This is in your book, you can open up your book, this is kind of small. Okay, all right, this figure is describing how ADH works. Okay, we have seen ADH week 1. Why do we see it in week 1? Endocrine. What makes ADH?
Adrenal.
What makes? See, this is why you get this wrong on the test. Makes. Okay, all of you just circled in pituitary and all dismissed it. Anti-diuretic hormone. You might have said it. Some of you might have whispered it. I don't know. Hypothalamus makes the ADH. Post-pit stores it. Okay, that is difference there. Okay, you have to be very particular in your language. I really think this is why test scores are low, is something as simple as that, right there, you got it wrong. Okay, so slow down and really think about what something's being asked of you, not for a test. Who cares? Who gives a flip about a test? In a year, 2 years, 3 years, when you're with a patient and a doctor asks you, go in there and make this patient better. I don't know. Okay, but if the doctor uses a certain verb, you have got to follow that. Okay, you have to be very precise with what you're doing in your language. Okay, okay, so the hypothalamus makes the ADH, post-it stores it. We have seen this before. We also looked at its function. Okay, when we did endocrine system, we did what do they do, where do they come from, type thing, where do they go? Right, I think that's what we did. Now let's look a little more detail on how it works. All right. So what we have is in the state of dehydration. So water levels are kind of low, didn't drink enough that day or whatever. What happens is the osmolarity of the blood starts to rise, right? Because you don't have enough water around. So with elevated blood osmolarity, the hypothalamus stimulates post-pit. Post-pit makes the ADH, and the ADH has its functions. Okay? So this is a very general overview of how this works. I want to add some more detail to it so that you understand how this happens. Okay, so what I want you to make, we're going to add figures. But not everywhere. I think it's like 3 little figures. Okay, right here. Yeah, right here. Figure 24. Oops, yes, 24. 24.4a. And then, yeah, and we'll put it here. I'll explain what I'm doing first, just giving you, I'll explain this in a second. Combine these 2 arrows into one. Okay, so we're going to add 3 figures. So what I want to figure for is each of these processes. Okay, so make a figure. How does elevated blood osmolarity stimulate hypothalamic osmoreceptors? This may take a little additional reading, okay, to see how that might happen if you have computers, textbooks, phones, whatever. To look into a little bit more to know what should I draw. The next figure, excuse me, again, these are things I want to collect, so good on scratch paper. You do it one per group. How does stimulating the osmoreceptors stimulate post-pit to release ADH. Okay, you see how this arrow is just an overview, it's saying it doesn't. I want to figure it shows how does it do it. All right, and then the last one is how does ADH stimulate the distal convoluted tubule and collecting duct to increase water reabsorption. So these two into one figure, all right? Does that make sense of what I'm looking for? This one I want to hand it in because I'm going to share it. I want to share all the different groups, how they put this together. Try to describe fully ADH. Got it? Understand? All right, get started. This might take you 20 minutes, 15 minutes.
Okay, so she wants to do.
How does blood osmolarity stimulate hypothalamic alpha receptors?
That's reduced. And what is the relationship?
Again, that's what she said. You gotta look at the molecular part of it. Increased blood stimulates. So how does it get that? How does it stimulate? You need to explain this arrow. It's this arrow right here. How does this happen?
Here, I'm gonna make it just
So she wants us to draw like, she wants us to explain how. Yeah. Like what triggers. That's what I'm reading. Hold on, let me read it. The increased osmolarity of blood stimulates the hypothalamic receptors. It's the first part, which stimulate the posterior to release ADH.
How does it elevate osmolarity? Okay, think about it.
What do you think?
This is the beginning, right? Yes.
That's explaining the condition of communication. We're already past that. We're right here. So, brought on hilarity. So, essentially, what happens is
So,
okay. So,
that's where you're starting.
okay, what happens is the blood volume actually
Increase
declines.
gamma sodium concentration increases.
So that would detect like a symptom lower blood volume, you can lower blood pressure. So the increased molarity of the blood stimulates the chemical receptors. So it's just low blood pressure.
That is high blood pressure. That's what it is. But here, it does. Fully dosed, blood pressure down. Just
Okay. You're right, you're right.
the protection is too long. What I don't understand here is increased cholesterol.
Essentially, you're losing water. Sodium stays the same. So if you have sodium molecules, they increase.
Okay. Where you need to add the sodium. Because the sodium is staying the same. Or the sodium is increasing.
Venom and then there's the AC.
Yeah.
There's something in the hypothalamus. Where?
See, it's made in the hypothalamus, and these receptors stimulate the posterior pituitary receptors. In your hypothalamus, and these receptors travel down posterior, and then they travel ADH.
So low H2O increased in the plus trigger hypothalamus.
Yeah, the receptors. The hypothalamus receptors.
So this is from where? So this would be
So essentially, the soldier does not use just
hmm?
food, smiling. Yeah.
Okay, so you do right?
Also, the ducks. The Timbers. Collecting.
Okay. So after the hypothetical sectors, what happens?
They stimulate the pituitary. See, they don't have that here. They don't have pituitary.
Yeah, they do.
I don't.
So hypothetical sectors. And this is 88 with these one. So this uses doesn't have to be for this one.
No, until
The pituitary gland releases it. So it's giving a signal from the thalamus. That produces a hormone called ADH release. You should watch the hospital.
when installed in the calculator, the channels allow to diffuse somewhere here.
So neurons, are coming to play, but not just right there. They're, yeah. Neurons change their so that you would want to have the neurons
Okay.
So, what are you gonna show, just not to show how. So, see, I just told you, stimulus from osmoreceptor neuron. What's the stimulus But you're thinking around the, I think, that's fine.
You wanna ask her if we have
Just retrying what's in the book. So I see that we're doing.
Well, you know,
That's why I was telling you to activate the secretion. Yes.
what I asked
It just sounds like you have repeating what's here, and that's all we're doing. I think what she wants is like what's actually happening. Like how is everything the receptor receiving that action potential. What's actually going on?
But are you
That's what I'm
ready?
trying to look for. Because this is explaining that, but it's not explaining what's happening in between. Like we know that ADH is coming from the posterior pituitary gland, but how is it what actually is happening? It tells the hypothalamus. So that's just one.
The sodium concentration.
So the sodium binds to something? What's it bind to? What's it saying? Exactly, that's what.
So you're on the right, you're on the right track.
What?
You're reading the same thing I am.
I mean, we're gonna. What do I wanna do? All right, let me go ahead and collect what you got. I know you're hard at that, but. You got something you can share with the other classmates?
I don't got shit.
You guys got something?
Water.
Just say something. You don't have to put your names on it, so you don't have to stay claim to it.
Okay, cool. I'm just gonna delete those names because as soon as I could.
No names, no names, no names. Keep this, huh? Yes, you can get it back. Yeah.
Yeah,
Yeah.
it's on the
Way more time. Well, really though, and Joel. I don't know how. I tried to say
I'm
Spanish.
gonna put myself in the answer, but it's right.
Okay, because I have one more subject in, I want to mention. Okay, let's see how I do. Some of these are pretty skeleton like, that's for holiday, right? Let me shuffle on, because I think I have an order. I think you guys just stand up there and just. You want me to do that? All right, I'm gonna go through these real quick. Okay, so, this group, osmoreceptors and hypothalamus. Going to post-pit, they're showing a more detailed view of this, of how this works, how it influences. So this is an excellent figure. It kind of adds to the original figure that we had, okay? So I think that's what a lot of these are gonna be, is what I know, is that hypothalamus, anterior post-pit. Yeah, you guys are all doing the same.
I can't tell them.
They can't tell
Yep. Yep. Okay, let me tell you, you all did the same thing, so feel good about that. You all read the line. Okay, let me, summarize real quick, what I was trying to get at. Really, what I was trying to get at, is make you think about this and talking about it, so that was accomplished. Okay, let me show you what I was hoping you would find. You wouldn't have to look this up. I don't think it's something you could have figured out on your own, I don't think. Okay, so what I wanted to see are the osmoreceptors. Osmoreceptors are stretch receptors. Okay, so I wanted to, so I asked more detail, how does that happen? How does osmolarity stimulate an osmoreceptor? How? Okay, so you have to look at cellular, the mechanism. What's going to happen to cause stimulation of a receptor? This receptor, any receptor. How does a receptor get stimulated? Something binds to it is one option. To be stretch receptors. Okay? So let's draw a blood vessel. These receptors are in the blood. Okay, these are capillaries in the hypothalamus. Okay, so these receptors have to be on these blood cells. Okay, so there's cells lining this thing right there, and you've got osmoreceptors that respond. Their mechanism, they're a mechanoreceptor, is stretch. Stretch receptors. Okay? So, if we have elevated blood osmolarity, we have increased blood pressure or decreased blood pressure in this case? Decrease. Okay, we have low water volume. Okay? So, these stretch receptors respond to a lack of. That must be a fire alarm. They did some weird things over the weekend to the building. I came in this morning, I had no internet. I don't know what happened, and they worked on it. Apparently, they increased the speed of internet to some number, I don't know. So they worked over the weekend, but anyway, okay. These receptors lack of stretch. Okay, because we have low blood pressure, it's stimulating the whole system to respond. Okay, so we have low blood pressures. These osmoreceptors are firing. So it's different from other stretch receptors that we saw in the, where do we see these? The glomerular capillaries. When they were stretching, okay, they would constrict. They were responding to the stretch.
What are the stretch receptors?
That was the myogenic reflex. Myogenic reflex responds to stretch. So if you have elevated blood pressure, okay, so you're getting pressure, stretch, they were constricting. Okay, so they were firing to stretch. These ones fired to lack of stretch. Okay, so that's what I wanted to see there. Just something that the osmoreceptors responding to stretch, in this case, low blood pressure. Okay? Okay, how does it stimulate posterior pit? This discussion, at least in one group, that we're in the brain, we're talking hypothalamus, we gotta be working with neurons. Neurons gotta be doing something here. Okay? So in fact, what we have, I'm gonna draw an osmoreceptor on that side. What we have is a neuron, got a color to this. Neuron, okay? When this osmoreceptor is stimulated by lack of stretch, it causes an action potential in the hypothalamic neuron. That is what does the release, well, the creation of ADH and the release from post-pit. Okay, so this simple thing is the figure that I'm looking for how does the posterior pit get stimulated. It's an action potential from the hypothalamus. So that what comes out here is ADH. Okay? Now, this ADH hormone goes in the blood. Blood ends up getting to the kidney, to the nephron. Okay? In the nephron, we end up getting the filtrate, and eventually filtrate ends at the distal convoluted tubule and the collecting duct. I've run out of time, so I don't get to show you how ADH does this part, which is not something I asked you to do. Oh, yeah, I did. I asked you to do all this in one figure. How does ADH stimulate the distal convoluted tubule and collecting duct? So we're going to just leave it at that it does it. And we're not going to have time to get into physiology of the That's the last thing, before we go, about aldosterone. So the only thing I'm gonna say about this, you're gonna have to look at it a little bit on yourself. Because this looks, oh, no, it doesn't look familiar because it's not on the board. That looks familiar. Okay, juxtaglomerular apparatus. One of the products from here was renin. So the last activity I had for you, which we ran out of time for, draw the renin angiotensins in the aldosterone mechanism. And what I would have been looking for is could you do this? You know angiotensinogen stimulated by renin and VGAR and so on. One of the effects is creation of aldosterone. So be sure you review this on your own. Come up several times. Okay? All right, we'll see you Wednesday.